The following is the video solution from JSDT Solutions. Question 7 says the graphs of f of x equals negative, and then we have b to the power of x plus 8 and g of x is equal to 3 over 2x plus 7 are drawn below. A and B, so A is negative 2 and 4, and B are points of intersection of f and g. B is the y-intercept of both graphs f and g. And the first question is to write down the coordinates of B. Okay, so this is the y-intercept. Now, in this, we could use either one of the equations. It would still work out. You see, at the y-intercept, the x value is 0. You see that we could still find it using f. So we can just do that. Use f of x and rewrite. And now, in place of x, we can just substitute 0. So we're just saying raised to the power of 0. Anything to the power of 0 is 1, okay? So this gives us negative 1 because of the negative outside the bracket, and then plus 8. So 8 minus 1 is 7. And so the coordinates of B are 0 and 7. And that is our answer. Moving on to the next question. Question 7.2 says, show that B is equal to 1 over 2. Okay, so finding the value of B. We can just use a point on this graph. You can't use this one. It's not going to work. So we can use A. Okay, so let's take the graph of f again. Okay, so that's the equation of f. And we're just going to find b using this point A. So negative 2 and 4. So negative 2 and 4. And so in place of x, we substitute negative 2. And in place of y, we substitute 4. So this is 4 equals negative. And then b raised to the power of negative 2 plus 8. Okay, so in this case, the coefficient of your base is negative. You might as well just transpose it. So now we have positive in front of it, and then raised to the power of negative 2 is equal to, and we still have the 8 here, and when we take the 4 over, minus 4 gives you 4. Okay, so at this point, we can just rewrite this so that it has a positive exponent. Right now, it has a negative exponent, but it's in the numerator. So we'll bring it down to the denominator, and now it is b squared in the denominator, and the numerator is 1, the coefficient that was still there, that invisible 1. And this is equal to 4, and then we can cross multiply. So this has a denominator of 1. Cross multiply, and we have 4b squared is equal to 1, and then divide both hand sides by 4, b squared equals 1 over 4, and then finally square root both hand sides. But just remember that this is the base of an exponential function. It cannot be negative. If not, it won't be an exponential function. Okay, so b is finally equal to, it will be positive or negative, but we know that b should be a value greater than 0. So b is equal to 1 over 2, and that is our answer. Okay, so there we have shown that b equals 1 over 2. Moving on to the next question. The next question says, write down the average gradient of f between a and b. Okay. So between A and B, we know that B is, actually, I just see that it doesn't matter, but we know that B, the point, the coordinate is 0 and 7. But it's not necessary to find this gradient, because do you see that A and B are points that lie on the graph of G. And we know the equation of G, meaning we know its gradient. So the average gradient between any point on this graph of G would be exactly 3 over 2. So that would be our answer. So we can tell them that the gradient of AB is simply equal to 3 over 2. And that is our answer. Moving on to the next question. Then question 7.4 says, write down the equation of the asymptote of f. So of our exponential function. So there's our exponential function. You can see the asymptote is always that value that was added or subtracted. Okay, we can say added. So it's in the form of, it's an exponential function. So it's in the form of a multiplied by b raised to the power of x minus p plus q. And so plus q, that would be your horizontal asymptote. So we can see that it is 8. And it's a horizontal line. So it starts with y is equal to. So y is equal to 8. And that is our answer. Moving on to the next question. Question 7.5 says, calculate the vertical distance between f and g at x equals -1. Okay, So between f and g. So here is x equals -1. We don't really know where it is, but we know this is -2 over here. So -1 is somewhere here. Okay, so you see that f is actually above g at this point where x equals -1. So we're just finding the vertical distance, meaning when we find this point over here, that y value, okay, whatever that is, and then for that same x value of x equals -1, we're going to have to find the y value of this graph of g, okay? And then we'll take that, and to find that vertical distance, we'll say the y value of f minus the y value of g, and that will give us the distance between that line where x is equal to -1. And that's all we're doing. So let's just find the y values first. So we can see that we were using the graph of f. We'll find the y value of the graph of f at x equals -1. Okay, so that is equal to, we know b is now 1 over 2. So the equation of f is negative and then 1 over 2 raised to the power of x. So we'll say negative 1 over 2 raised to the power of -1 and then plus 8. Okay, let's find that y value first. So that's going to be 2, -2, 8 minus 2 is 6. So this is 6. And then we need to find the y value of g as well. So the y value of g, when we substitute, it's a straight line. It was 3 over 2x plus 7. Okay, so that is 3 over 2 times -1 plus 7, which is 7 minus 3 over 2. And you can write this as 14 over 2. So that is going to be 11 over 2. Okay, so the y value here is 11 over 2. And all we're saying is, because we can see that the graph of f, the red graph, is above the graph of g at this point, we're just saying the y value of f minus the y value of g. And that will give us the vertical distance. Okay, so vertical distance equals, so we'll take f of -1 minus g of -1. Okay, and that is just 6 minus 11 over 2. We can rewrite 6 as 12 over 2 minus 11 over 2, which is 1 over 2. So our answer is 1/2 units. And that is it for this question. Okay, and that is the vertical distance. 7.6 says, describe the transformation of f to h if h of x is equal to 1 over 2 raised to the power of x minus 5. Okay, let's look at them side by side. F of x was negative and then 1 over 2 raised to the power of x plus 8. And h of x is, as we can see. Okay, we can see it already, so we can just compare. So what happened first? Notice how this is no longer negative. Okay, it's now positive here. So the only way you could have done that is if you took the y values of f, right? So to find h of x, they clearly took the y values of f and they multiplied them by -1. Okay, so we said negative f of x. And so that will cause you to say negative and then substitute the graph of f of x in here. So this is negative and then 1 over 2 raised to the power of x plus 8. And when you distribute, you would get positive 1 over 2 raised to the power of x and then -8. And this is what it would look like once you multiply the graph of f by -1, okay, the equation of f. But then that doesn't really explain everything, because this is what it would look like. So what did we do to get from this to this point? Okay, so do you see that now we've got this side, great. But now we're at -8 here, and here we're at 5. How did we get from -8 to 5? So that's the asymptote, right? So the graph now lies above the asymptote first, and it's decreasing. But then -8, y is equal to -8 would be your asymptote. But this one has y equals -5. So from -8 to -5, we clearly shifted this graph up. By how many units? We moved it up by 3 units, okay? From -8, -7, -6, -5. So that's what happened. They simply applied this, and we'll speak about what this means, and then they shifted the graph up. So h of x clearly went through this transformation. So we went negative f of x and then plus 3. And so you see that if you do that, you end up with h of x, which is equal to 1 over 2 raised to the power of x minus 5. Okay, so now let's speak about what happened, okay, the transformation. So we said negative f of x. you're applying a negative to the y values. When you do that on a graph, what you're doing is, let's just take a point, 1 and 2. If you make the y values, all the y values of this graph negative, this point will now become still 1, but now the y value is negative 2. Okay, that's if you multiplied its y value by negative 1. It becomes negative 2. So what happened? How did it move from here to here? Well, this was not a shift. Okay, it didn't shift up or down or anything like that. So if it's not a shift, and we can clearly see we multiplied by a negative 1, it was a reflection. But reflection through what axis? It would be through the x-axis. Okay, it was here before and now it's reflected here. So it's a reflection in the x-axis. And then what else happened? This graph was shifted 3 units up as well. So those would be the two things that happen to f so that it can become h. So we can finally tell them that the graph of f was reflected through the x-axis and shifted 3 units up to obtain h. Okay, and that is our answer. Moving on to the next question. Question 7.7 says, for which values of x is f of x greater than or equal to g of x? Okay, so f of x greater than or equal to, let's look at where they are equal and then we can see where they're greater. And this really, from 2 questions up, this really helps us a lot with this. Okay, so you can see that the graph of f is marked in red and the graph of g is marked in blue. Where is the graph of f of x greater than or equal to g of x? Well, they're equal at a and b, and then all through here, do you see how the graph of f lies above the graph of g? So it has greater y values than the graph of g, and so that's what we're looking for. So it happens all through here within this region, and so we can see that that starts at negative 2. This is the x value that we have here, and it ends here at this y-intercept b. Okay, so the x value that it ends at is 0. So this works all through where x is greater than or equal to negative 2, but less than or equal to 0. Okay, and that will be our answer. So we can finally tell them this means that x is greater than or equal to negative 2, but less than or equal to 0. You can write it like this, or you can also write it like this. So we could say x is an element of, so in interval, so this will be negative 2 to 0, but we're going to use square brackets because you see that the graph of f and g were equal at x equals negative 2 and 0. So that's why we had greater than or equal to and less than or equal to. So we'll use square brackets for both. So if you write it like that or like this, it's fine. And that is it for question 7.